So stars basically is going to be a 1 hour class, right? We're going to look at regularization and the techniques we can use for to prevent overfitting. We've already like introduced overfitting. We've explained the concept and all of that. The classes or the class recording are available already. So if you've not gone through it, please do. And how is the project going? I want responses. I want to know how is our project going so far. How is the project going so far? Has anyone like concluded with the project yet, or are we still just use a percentage, just use percentage to gauge your progress so far. How many percent progress have you? Oh, 30%. So what's our progress generally? Just express it in percentage. I mean, know exactly how it is going on your end. What's not fine about it? You're free to use the group chat, like the Q&A, like to address or to like ask questions regarding the project. It's not necessarily like an isolated stuff, although it's an individual project, but still yet you're free to ask questions and all of that. So the point of the project is for you to understand exactly the whole process. So if you can understand it, like I really don't pay much attention into how you like did everything, right? If you had to like ask some persons to help you explain how to do this stuff and all of that, but point is for you to like, although you're still it's for you to like do the whole thing from start to finish your own, because that is only how you are going to understand the entire process. But at at each step, you can actually ask for help. It's probably challenging. Okay, so remember the deadline is on the 20th. That's Friday next week Friday. So anything you're doing, please try to wrap it up, because there is no extension. Like, I'm going to sound this, there is no extension for this project, because I literally had to extend this our project by a week, so we have more time to do it. So please, if you've not like if whatever it is you have to do, please just try as much as you can to do it under the days we have left, because I'm giving up officially every single thing but the graduation on the 28th. I think it should be 28th of this month, right? So that is a week after our submission. So after the submission, we're still going to have to grade, and we're still going to have to present, right? So we have literally a week to do all of this. So there will be no room for extension at all. And this project is a very important aspect of this program, right? So it's a very, very important aspect. So yeah, so I can see most of us are still not done. 60%, 50, 45, 75, 30. Please try to hasten up. I know it's not easy, but yeah, it's fine. Like, just take your time. If you would have like sacrificed more time than usual, please do that. All right. You'll definitely enjoy the benefits. All right. So today we are going to after this class, we're going to have our class on Saturday, which is going to be our official last class, and we're going to be wrapping it up with data science, right? So hoping to see everyone in that class. I know most of us have, like, I can see we have those 30 persons on this call. I don't know where the rest are, but I believe I'll just have to believe that it's because this is not our regular class day. So that's why we're having this number. But on Saturday, I would love to have everybody in class. All right. So because after class, we're just going to talk about some other things going forward, right? I'm also going to even, yeah, I know I'm something about an advanced class, right? We are going to be seeing details about that. If not this weekend, then early next week. All right. So you can, for those that are interested, you can just prepare yourself. All right. You can prepare yourself for it. So you're going to get more details regarding that, um, like in the coming days. Okay. So let's kick off. So today we're going to look at regularization techniques. I'm not really going to talk a lot. I'm not going to talk a lot. Just I'm actually like I'm trying to conserve strength, so I'll just um maintain the space I am on currently. So regularization techniques, we are basically um looking at how to. Anyways, I wanted to just go over some things we've done, but I think at this point we don't have the time, and I believe we kind of have an idea generally of what we've been doing so far. So, and I think just some of us need more time to go over the classes and everything. So this is just an addition to it, and I believe this is not going to be like complex or like difficult to understand. So regularization, basically, I've mentioned this several times in the previous classes. So I said regularization is a technique in machine learning that we use to prevent overfitting. I've explained what overfitting is, okay? So overfitting is when your model learns too much. It begins to learn unnecessary details, it begins to learn noise and things in the training data. So when it now sees new data, it's unable to generalize and give good predictions, right? So that's what overfitting is. So one of the solutions to overfitting, as I gave in the last class, was what? Regularization. So that's what we're going to talk about in this class. So I'll talk about regularization, the types, and how to implement it, and we're done for today. All right. So it's not going to be a long class. So as you can see here, the technique, this regularization is a technique used to prevent overfitting by adding additional information to the model. All right. So this additional information is basically what we call penalty. All right. So they are trying to penalize, or we use the terminology penalty. You're trying to penalize your model, right? So probably your model is doing what it's not supposed to be doing. So you penalize it. You tell it that no, don't do this. Don't learn unnecessary details. All right. So the penalty you add to your model to prevent overfitting are regulation techniques, right? So that is basically what regularization is. And we can see on the screen here that it helps ensures that the model performs well on new unseen data by discouraging overly complex models that might fit the training data too closely. So we've looked at overfitting and all those concepts. I feel most of these things should not sound strange to us, right? So when you have remember I told us that one of the reason for overfitting is complex models, right? So overfitting basically tries to simplify our model for us. So when we use any of these overfitting techniques, it does a kind of decoupling, right? Trying to simplify the model so that it doesn't learn too much than it needs to. Okay, so that's in essence what the regularization does. The problem of overfitting occurs when a model. So I've explained this already, right? So you already know what it is. So we've also looked at bias and variance trade-off. Okay, so all these things have been looked at already. So let's just move to the types of regularization we have. We have two types of regularization. We have L1 regularization, which is also called lasso, all right? So we have L1. This is the main thing from this class, the types of regularization techniques. Like these are the things that I need you to pay attention to. We have L1 regularization and we have L2 regularization. Okay, so L1 regularization is called lasso, while L2 regularization is called ridge. Okay, so this we also have the next, which is a combination of the two. It's called elastic net regularization. So these three different techniques, they are the regularization techniques that can be used to prevent overfitting, and they have implementations basically in sklearn, right? So let's just quickly look at them. So what now? If for those of us that have been exposed to ML before, you should know that, or you would know that we have what we call lasso regression, right? And we also have what we call ridge regression. So lasso and ridge regression, they're basically like a type of linear regression that has this regularization techniques embedded into it. Okay. And you come to realize that some of these algorithms that we're looking at, they have the option of using either of these regularization techniques, right? Which we are actually going to see in some minutes. So what's the difference between these regularization techniques that we've mentioned now? So for lasso regularization, I'm going to see a lot of regularization today. I hope I don't just bite my tongue. So for lasso, we have what it does basically is that it tries to there's what we call coefficient, right? Coefficient can also be called let me just try to double the memory a little bit. I think in the first class in the class on linear regression, I mentioned coefficient, and I said that coefficient can also be called what in machine learning. Like we call them coefficient, or we can call them what. So what's the other word for coefficients? Because I was about to say, but I was like, wait, let me know if we can still remember what we discussed in previous classes. So coefficient can also be called what? Can anyone remember? Anyone? Okay, so let's just move on because of time. So coefficients are also called weights, right? I told you about weights, I told you about coefficient, and I told you about what? Thank you, Felix. And I told you about parameters, right? These are the three things. They are the same thing used interchangeably. So you can see the of these, just know they're referring to the same thing. All right. So what lasso regression tries to do is that it tries to drive coefficients, like it tries to drive the weight of your features to zero. Remember, when you are training a machine learning model, what your machine is learning, or what the computer is learning, they're learning weights that is attached to every single feature or independent variable. So those weights will determine the influence each feature has on the prediction. Okay, so the more weights that the more features basically that your model have, the more complex your model, right? So extra feature or a lot of feature is can lead to complex models. So what lasso regularization does is that it drives some of the coefficients in your model to zero. So when something is zero and you multiply something by zero, what will you get? Right, you will get zero. So whether you multiply anything, you multiply by zero, give you zero. So when the coefficients are driven to zero, and in your formula, most formula, you multiply your most of the segment algorithm formula, you multiply your coefficient by your feature value. All right. So when you drive the coefficient to zero, you are essentially removing that feature, right? You are essentially, so basically what lasso does is that it removes some features, right? Basically, so it removes those features that are less important to your model. So when your model is overfitting and you apply lasso regression, what you're essentially doing is you're removing features, and the approach in which the features are being removed the approach that is used in removing a feature is by driving the coefficient of those features to zero. So lasso regression will select those features that are less important, right, and drive their coefficient, their weight, the value that is attached to them to zero. So at the end, you don't have that feature in your model, right? So that is basically what lasso regularization does. Like, if you can understand that, you've understood lasso regularization, all right? So you can see that L1 regularization can drive some coefficient to zero, effectively performing feature selection by removing less important features, right? So that's just what it does. So examples, you can see lasso regression, as I mentioned, is an algorithm, right? It's a machine learning algorithm that has lasso regularization embedded. So lasso regression is useful when you have a high dimensional data set with many features, and you want to identify and retain only the most important ones. In our last class on Saturday, we're going to look at feature selection. We're going to look at how to select features, right? Because you might have a situation where you have a lot of features in your data set and you don't know which one to use because you don't want to have a complex model, and right. So there are techniques used in selecting features, and one of those techniques is lasso regression, right? We're going to discuss the remaining techniques on Saturday. One of them is lasso regression. So lasso regularization. So lasso regularization, or L1 regularization, can be a regularization technique, and it can also be used for feature selection as well. All right. So it does these two things. So what are the advantages and disadvantages? So advantages: it can reduce the number of features, making the model simpler and more interpretable. So basically, when you reduce something, it makes it simpler, and you can also actually understand it better than when it was complex. This a disadvantage is that it might not work well with highly correlated features, as it tends to select one and ignore others. So we talked about multicollinearity when we talked about the assumptions of linear regression. So correlated features is something that you always need to pay attention to, all right? When like building a model. So correlated features are those features that they are basically doing the same thing, right? So it's just like a redundant feature. So if you check a particular feature and you check a correlated feature to that feature, you realize that they have the same impact on your label or your target variable. So removing one of those correlated features is essentially a good practice, right? Because it's not going to affect your model in any way. So leaving them there is going to make your model more complex. All right. So that's just it about correlated feature. Anyways, that's not the discussion for today. But what we are looking at here is that L1 regularization may not work well with highly correlated features. So it doesn't perform well when you have correlated features. So it doesn't know how to handle them, right? So those are just what we have here regarding L1. So what you just need to take out from this is that L1 regularization is one of the techniques used to prevent overfitting, right? And it does it by trying to drive down the coefficient of your features, right, to zero. So the coefficient it drives down are those coefficients that are less important. So the way it picks up the less important feature is part of its inner working, right? So it's not something that we'll start discussing now, right? So just know you can, if you are curious to know, you can go and do further research on that. But that is essentially how it works, and that's it for that. Okay. So we have a formula, right? So this stuff I circled here with the red stuff is the formula for regularization. So this is your loss function, basically. The loss function is the function that is used to calculate the is used in training, basically, to calculate the error of your model, right? So normally you have just the loss function, right? But when you add a regularization, in this case, L1 regularization, you are now adding an additional formula here. So this formula is what drives down the coefficient of less important features. So obviously, we're not going to start dissecting this and explaining what this formula does, right? So this is the formula for L1 regularization, just so you know, and it's added to the loss function to reduce the complexity of the model by driving down the coefficient of your features, not any feature basically, the coefficient of less important features to 0. Okay, so that's it for that. So we have L2 regularization, which is also called ridge regression. All right, so ridge regression basically is another approach to reducing overfitting or preventing overfitting. So what ridge regression does is that it does similar thing to lasso, but it doesn't completely remove any feature. It just reduces the weight or the coefficient of certain features, right? It reduces it significantly to a point where it is close to 0, but it doesn't like eliminate it, right? So that is what ridge does, as is straightforward and simple. So lasso removes feature by shrinking the coefficient to 0, while ridge shrinks the coefficient towards 0, but not necessarily 0. So it still retains those features. So this ridge regression is used in situations or in cases where you don't want to completely eliminate features, because you want you feel some of those features are still like important in the model, so you don't want to completely eliminate them. All right, so that is a case where you might want to use ridge regression, right? So it depends on your use case and it depends on your data set and a lot of other things to consider. But these are the two most commonly used regularization techniques. Okay, so as I said, we have ridge regression. Ridge regression is an adaptation of linear regression. So it is used when all features should be retained, as I said, but their impact should be minimized to prevent overfitting. So the impact is going to basically be shrinked, right? So you don't really feel their impact so much, which helps in simplifying your model. All right. So the essence of all this thing is just to reduce the amount of things that your model is learning, because your model is learning too much. So you want to like reduce it to a point where it doesn't learn unnecessary stuff. All right. So that's why we are applying all of these regularization techniques here. So we have a disadvantage and advantage as well. Right, one, the advantage, it is more stable and effective with correlated feature, and it does not perform feature selection. So all features will remain in the model. Okay, so that's it for. So there's really nothing technical about this regularization. I'm just trying to give you the show you the techniques that I used. All right, so this is the formula, right? So the same thing, but it has different formula compared to lasso regression. So we also have the third one here, which is elastic net regularization. We have elastic net regularization. I hope everyone can hear me. Some persons are complaining of network. So we have elastic net. So what this elastic net does is that it combines L1 and L2. All right, it combines L1 and L2. So it just gives you the best of the two worlds, right? So it balances the benefit of lasso, feature selection, and ridge handling correlated features. All right, so providing a more flexible regularization approach. And it is best used when dealing with many features, some of which may be correlated, and you can select features while also reduce the impact. So this is just showing you the different strengths of the two types I just mentioned, right? So these are the advantages and disadvantages here. Flexible balances feature selection and shrinkage, works well with correlated features. more complex to tune due to the need to balance two regularization parameters. So that's actually it for the techniques. We have L1, we have L2, and we have elasticness, which combines two of them. So the other thing we're going to be looking at is how we can implement it in sklearn. So in sklearn, we basically have most of these things embedded. All right, we have most of them embedded in different algorithms, right? But Lasso is an algorithm on its own. It can also be an algorithm on its own, which is an adaptation of linear regression. So you can see here that we have Lasso imported from linear model, and we can see we have a parameter here which is called alpha. I'll explain all of this, right? So let me just go through this briefly. So we have regularization, which is rich. So you can see we can import rich from linear model and use it as well to train the same way we can train with linear regression. So this alpha, we're going to see exactly what alpha does. We also have elasticness as well, so we can import it. And you can see we have alpha and we can see we have ratio. So this L1 ratio is basically asking us what ratio should we have between L1 and L2. So in this case, we have 0.5. So this 0.5 basically means we should apply L1 and L1 should have 50% contribution, while L2 should have 50% contribution. If you have 0.2 here, then L1 will have lesser contribution, which is going to be 20%, while L2 will have the higher contribution. So depends on what you want to achieve, basically. If you want more feature selection and less feature shrinkage, you can use a higher L1 ratio by 0.7 or 0.8. Like basically, having the knowledge of all these things will just help you decide, inform your decision, basically. So we also have the implementation in different algorithms. So we have, okay, this is Reach, this is Lasso. We have logistic regression here. Okay, so you can see that in logistic regression we have what we call penalty. Let me create a notebook first. So we have what we call penalty in logistic regression. So penalty basically is the regularization technique you are applying to your logistic regression. Okay, so it's a parameter that gives you the option to select either of the regularization techniques that we just looked at. All right, so you can tell it should use L2 regularization, you can use L1 regularization. So we also have support SVM. All right, so in SVM we have this parameter here. So we're going to look at all of this, but let me just go through everything, right? So these are just other implementations, and so we can see we use grid search here to select the best alpha. So we're going to talk about also what alpha parameter is, right? So, but let's see. Okay, that's just it. So let's go straight to implementing it in sklearn. And I hope everyone is still following and we still on track. All right. So let's see how we can just implement M. Okay, so I'm gonna just import everything. So from SK, give me a second. Sorry for that. So let's just continue. So we import the algorithms that we are going to use. We have linear models, import lasso and reach from scale dot svc import s sorry svm rather import svc and from linear model again. Let me just import separately from sql dot linear import logistic regression. But let's just use this ones for now. Okay. Okay, so thank you for noting that John looks in. All right, so I think that should work. So how am I getting around again? Linear model. Okay. So using lasso and reach regression. All right, so as you can see here, we have what is that regularization technique that we're doing? So we have lasso here and reach. So we'll do the same thing as we always do when we want to like initialize a model class. So you can come and just say L1, right? L1 model. I can just say lasso. So lasso has parameters, but the most important parameter here is alpha. All right. So alpha here, if you scroll down, alpha basically means the strength is the strength of your regularization, basically, right? So in this case, you're already using a regularization, right? This particular model that you have here has regularization in it already embedded in it. So just look at this lasso model or algorithm here as a linear regression algorithm, but with L1 regularization in it, right? So that is just the difference. So when you come here to specify alpha, what you're trying to say is you are trying to tell the algorithm or the model that, see, I want you to increase the power of the regularization. Let the penalty be strong, all right? So alpha is a hyperparameter that you can also play with. So the lower your alpha, the lower the penalty on your model. The higher your alpha, the higher the penalty, right? So the more alpha, the more regularization. The less alpha, the less regularization. So that's just basically what alpha does. So you can see it here. Alpha in the default alpha here is, I don't know, I can scrub. So you can see here that the explanation for this lasso is linear model trained with L1 prior as regularizer. This is just for me to bite my tongue. So this is what lasso regression. Yeah, so this is a formula here, okay, as we saw. And you can just read every other thing. So The alpha here is a constant that multiplies the L1 term, controlling regularization strength. This is what I just explained now. So the higher your alpha value, the higher the regularization strength, the lower, and vice versa. So that's basically it. So when alpha is equal to 0, the objective is equal to ordinary least square. Now, I need you to understand some things, right? By default here, alpha is 1. So that one is what makes this particular algorithm a lasso regression. So when you now decide to make your alpha 0, what you're now doing is you're now converting this particular algorithm now to a normal linear regression, because there's no regularization there again. Because anything you multiply by 0 is what? 0. I hope we are following at this point. So that's basically it. You can now see that by default alpha is 1. So in your hyperparameter tuning, you can in your params dict, right? You can include alpha as a hyperparameter you want to tune, right? So you can put different values. You can start with 1. You can go lower. You can go lower to, let's say, 0.1, come to 1, come to 10, 100, like that. So, but before you start considering regularization, you should ask yourself, is my model overfitting, right? That is what you should check before you start. So you don't just do this straight out of the box. You don't just say, because I've learned this now, let me just go include it in my project. You should ask yourself, is my model overfitting? Then if it's overfitting, then you should now start considering all these things that we're talking about. But if it is not overfitting, there is no need for you to do any of this. All right. So you should always think about all these things. You should think as a data scientist and not just as someone that is trying to do garbage in, garbage out. Okay, I've learned this thing and let me just go and apply. But you should ask yourself, why are we using this? In what cases are we supposed to use this? All right. So that's basically it, right? So it's only in situations where you are overfitting, and I've showed us how to identify model that overfits, or model that overfit. Basically, I've showed you how to identify them. So by now you should be able to know if the model you are building is overfitting or not. So in this case, we can just say alpha is 10. All right, we can select 10, and we're going to use this to now train our model. So I can come here and just say model dot fit rather x train y train. So just go through the normal process, right? Go through the normal process of training your data. I just remember something now. I talked about ROC to do that. But let's just continue. I don't know why I've been pushing this. So because that ROC curve is something that I expect to see in your project, right? Because you have to compare the performance. All right, so let's just finish with this first. So this is what we have for L1. So for L2 is basically the same. So you've imported reach, so you just come and say L2, right? L2 model. So you say reach, and then you have alpha. So the alpha in this case is the same thing. So reach regression is still the same linear least square with L2 regularization. So linear least square is your linear regression, and so exactly the same thing that we have. So the default is 1, which multiplies the alpha with the L2 term, controlling regularization strength and all of that. So these are just the two basic regularization techniques we have. So we can just say we want it to be 0.1, then we want to reduce the regularization strength. Let's say we apply 10, and we use the value of 10, and then we realize our model is now going towards underfitting. It's becoming too simple. That means we are penalizing it too much. So you now have to reduce the alpha value, right? You can reduce it by 1 to 1. You can reduce it to 0.1. You can reduce it to 0.001. Probably what your model needs is just a little penalty, like a little penalty, right? So that's it. You can just come and say L2 model dot fit X train and Y train. So you can then just go and do what you're doing. All right, so let's look at the other one that we have here. We have logistic regression. So we have log model. So logistic regression basically has parameters that can let you control your regularization as well. So if you click here, you're going to see that we have penalty here. So penalty is a parameter in logistic regression that allows you to choose whether you use L1 regularization or L2. So by default, you can see I actually said that some of this algorithm has regularization built in already. Okay, so by default, logistic regression is already using L2, right? By default, so you can leave it there or you can change to L1. And you can see we have this, in this case, we have C, and C is, in this case, is what we use in controlling, our regularization strength, right? So it's just like the alpha in lasso and ridge regression. So that's what C is. So all these parameters, hyperparameters you're seeing here, they actually mean something. So, but the ones that are more common and the ones that are more important are the ones that we've been looking at recently. So that's what C does. Yeah, the same thing as alpha. All right. So you can just define or set your C to be whatever value you feel you want it to be, or you can use hyperparameter tuning like grid search or randomized search to select the best combination. All right. So you can come here and say penalty and just say L1 or L2. But by default is L2, and you can say C. Okay, for this L1, I want the strength of the regularization to be very strong, so I can put it to be 100. Yes, it's going to penalize your model a lot. So your model, if you actually try this, you can try it if you have time. You try creating a model with normal parameters, and then try building a model with this parameter where you have a lot of regularization penalty. So that the model will begin to underfit, right? Because it will penalize it so much that it will not learn as much as it should again. So we also have another option here, which is your elastic net. So your elastic net is an option, all right? So you can select elastic nets and you can select none if you don't want anything, right? So you can see the definition of each of them. No penalties added if you select none. Add the L2 penalty term and also the default choice. Add a L1 penalty term and elastic net. Both L1 and L2 terms are added. So when you use elastic net, you have to include another parameter, which is the ratio. All right. So let's see if I can find it here, because we have L1, L2 ratio. So okay, see it's your L1 ratio. So when you use your elastic net, you have to include your L1 ratio. So to tell your model that okay, this is the ratio I want for my L1 and L2 parameters. Yeah. So I hope that is actually clear. So this class is basically a very straightforward class. It's something that we are just building on what we've discussed already, just showing you how to implement them. All right, so you can actually, as I said, depending on how your model turns out, you can decide to include this in your model by preventing the overfitting you are seeing. If it is not, then there is no need. But it's very necessary that you have this knowledge, because in the future you might encounter a situation where you need to deal with overfitting, and then you'll be thankful that you got to know about this. So let's just look at the last one here. Let's look at support vector. So most of the model have parameters that can help you select L1 or L2, right? So these are just the ones that the common ones. So you can actually check it out. Some of them have. I think most of them should have if you actually check well. So we have SBC. So I can just say SVM equals to SBC. You see that SBC has it has C here. All right. So let's just look at what this particular C means in this case. Okay, so the C here is the same strength, and you can see that your SBC uses L2 regularization as a default. So I think most of them already have regularization embedded by default. So you can now control the strength of that regularization. So for SBM, I think you can't even change it. So it uses L2 regularization as default. So you can see that it's L2 that you're using here. So you can use the C. So if you don't want it at all, you can just change your C to what? If you don't want this L2 parameter, what will you do in this case? Exactly. I think that's just straightforward. Exactly. C will be equal to 0, right? So to multiply the value of the L2 penalty, which is going to be 0, and then there will be no regularization basically. So you can now see how you can tweak stuff. You can just change stuff at your will and depending on what you want. All right. So that's basically it for regularization. Let's see. So we've looked at what regularization is, the types, L1, L2, what they do, and the combination, which is elastic net. All right. So we looked at the implementation and how we can implement regularization as just it's very simple and straightforward. All right. So this is only done when you see that you have your model is overfitting. Okay. So these are some practical considerations. You choosing the right regularization technique depends on the nature of the data set and the problem requirements. Lastly, is useful for feature selection, which is beneficial with dealing with multicollinearity, and elastic net combines both advantages, right? So tuning regulation parameters like alpha and lasso, alpha and range and lasso needs to be tuned to find the best balance between bias and variance. So all these things you can use cross validation. This hyperparameter thing we looked at in the last class to select the perfect or the optimal regulation parameters, right? So I think you already know how to do this. So these are some common pitfalls. Make sure that as you're trying to prevent overfitting, you don't over penalize your model. So you don't add too much regularization as it can lead to underfitting. So in the process of trying to stop overfitting, you can actually now drag yourself into another problem, into underfitting. So you make sure that you balance your model so that you don't overfit and you also doesn't underfit at the same time. So as you're trying to punish it, as you're trying to penalize it, you ensure that you don't over penalize it. You penalize it appropriately. All right. So that's it for regularization and yeah, the regulation techniques we have. So as I said, this class is supposed to be a very straightforward class, very quick class, and the aim is just to bring you to understand what regularization is and the techniques, and how we can use them in preventing overfitting. Okay, so I promise I'm going to just finish this class under an hour, which I'm going to do, and yeah, the ROC stuff where it's going to be I'm going to do that on Saturday class. So there is really nothing there. Like there is really basically what we are trying to do is trying to just compare our model performance using the ROC ABC curve. All right. So it's just few lines of code and then like you're done with it. So it's a way to like visually like present your performance of different models that you like created. So we are going to do that. So Saturday class is going to be a bit lengthy. We might stay for more than 2 hours, right? We might stay, let's say, 2 hours, 30 minutes or more. So just prepare yourself ahead of the class because we'll be wrapping up with everything. We're going to do it. We're just going to wrap up with everything. We're going to talk and just like conclude the entire class, right, officially. So I believe you've all gotten to understand one or two about regularization, and it should help you, right, going forward. So if you're no attendance, right? Yeah, no attendance for today. Like attendance has even like stopped, like it has ended. Our class was supposed to officially on the 12th week, which was last class on Sunday. So every other class we're having going forward is just extra class. So there's not going to be attendance. We won't be having any attendance marked. All right. So you can decide to come for the class. You can decide not to come for the class, right? So there's really nothing holding you again. So that is it for today's class. Thank you very much for the time. I'm actually happy that we've done this. So we know that we only have one more class to go. So what we have remaining, think we have feature selection and we have pipelines. Yeah, like how to use pipelines in sklearn and feature selection as well. Let me show you the material. I've dropped the material already. So we're going to be looking at feature selection. We'll just start by introducing what we mean by the course of dimensionality. So, and we're now going to see how we can apply some techniques to reduce dimensions. So we'll now look at feature selection techniques and a whole lot of things. And you can see we have in this embedded method, right? We have lasso regression. So this is a technique for selecting features. So you can see what I was talking about, lasso regularization, which can be used to select features. So it's part of what we're going to look at. And then we're going to look at building pipelines in sklearn. So pipelines is just a way to kind of make your workflow simpler, basically. Right. When we look at pipeline, you actually love it. Like it might even change the way you do your project because it simplifies the whole process of pre-processing and all of that. So don't worry, we'll look at it on Saturday. And I think that is just also we're just going to look at dimensionality, feature selection, and then pipelines. Like it's not going to be a short class. It's not going to be a short class. We are going to take our time to look at it. So just prepare the end of the class. If you're going to miss any class, it shouldn't be the last class. It shouldn't be the first class and the last class, right? I believe this is a common knowledge. If you are doing anything and you want to miss maybe for some reasons, it shouldn't be the first lesson or the first meeting, and it shouldn't also be the last meeting. So I'm telling you now that you should try as much as you can to attend the class on Saturday. I'm looking at it probably might start by 3 p.m. I'm not sure yet, but it's definitely going to be going to 3 hours. So yeah, that's going to be it for that. So thank you very much for your time today. I don't know if anybody has any question. And I don't know if anybody has any question for this particular class. If there's no question, then we'll just have to call it a day and close the button. I forgot to even ask our class rep and assistant if there was anything that I needed to know about the project, about anything at all. Like, is there anything I need to know that I'm forgetting to address? Please, Nigeria, and you can just have the floor. If there is none, just let me know, and then we wrap up with it.
Good evening, sir.
Yeah, good evening.
How are you doing, sir?
Yeah, I'm doing very well. Thank you.
Yeah. Thank you for your sacrifice. Thank you for this short lecture. We appreciate you so much. And there's not really anything from my side, but just to also clarify, there are people that are still asking for the link download the data set, but we are giving them all the best, we are answering their responses. And then I want to also thank everyone for your resilience throughout this course. Like I know it has been challenging at some point. Some of my colleagues want to just give up, but I mean I'm so proud of every of my colleagues here. Like I mean I can see the resilience in us. So I really wish us well in our project. Just know that the, the goal is to just finish well, and I'm proud of all of us. Thank you for everything. Thank you so much.
All right, thank you very much, Gideon. I do appreciate that, and you've actually done a lot with your assistance. Um, yeah, it's really nice having you. Nigeria, is there anything you have to say before we call it a day? Oh, your network is really not at the
Can
best.
you hear me now, sir?
Yeah, I can, but I think your network is just messed up a little.
Okay. Is it breaking bad?
Yeah, you can go on. I think I can hear you.
Oh, okay. If it's breaking too bad, then you can just let me know. Maybe I'll leave it till Saturday. For now,
Yeah.
I just want to say, okay, thank you so much for everything, sir. And the project, if some people are like me, we started a bit late, but encouragement to everyone, really. Person body just dey hot anyhow, but we'll be fine. So just a reminder to everybody, just find a way to break everything and take it one step at a time because yeah, that's the same thing I'm doing. And thank you so much, sir. See you on Saturday.
Yeah, thank you very much for that. And for the project, I think it's very normal. Like if what you are doing like is not challenging you or giving you headache or tough time, that means you're actually not like growing. You're not like moving to the next level. So if it is easy for you, then um you're just like staying in your comfort zone basically. So I think it's essential that the project challenges you and brings you out of your comfort zone, like, and make you do more than you just put more effort basically. So once you pass the stage and you look back and you'll be like, oh, was it this thing that was giving me like all this stuff then? It basically mean that you've gone from level X to level Y. You've jumped a level higher. And that's how you basically upskill. That's how you basically like grow in your career by taking on challenges and doing stuff that are new, right? So there's a phrase that I actually like. Two quotes basically: "Do it afraid," and also "Fortune favors the brave." So whatever you're doing, like you don't have to understand it clearly. You don't have to have clarity. You don't have to like have it figured out completely. You just need to be bold enough to start it. All right. There is nobody that ever did anything significant or worthwhile that had complete clarity. It was scary. It was scary basically, but they picked it up and told themselves that even though this thing is looking like a huge deal at this point, I'm going to actually surmount. I'm going to prevail, and I'm going to conquer. So it takes boldness, basically, for you to pick up things like this. And I think you all have showed boldness for the past 3 months, almost 3 months now. And this last part is it should be nothing. If you are doubting yourself, you should look back. Basically, just look back. That is just all you need to do. Just look back. I'm like, if I can get to this point, then this is actually nothing. I think the thing that might just be a little challenge might probably be the timing. I think the timing is okay. To be honest, to be fair with you, the timing is okay. But for someone that is just doing it for the first time, the projects, just try to maximize your time, all right? And definitely you're going to not regret it. You'd be happy with yourself at the end, basically. So please don't give up. I'm begging you, don't give up. All right. If you don't want to stay where you are, like if you want to like move forward, don't give up. So that is your little bout of motivation for today, and I know that Justice is very happy because I think this is like his daily bread. Anyways, I'm just joking. So see you on Saturday. Good night, and do enjoy your night and the rest of the public holiday today. So, gracias. So, like, put down what you learned in today's class as well.